If winglets save fuel on airplanes, then why don't fighter jets use them? It looks like an obvious upgrade. But in aviation, the obvious answer is often the wrong one. And the real reason has everything to do with speed, physics, and survival. If winglets save fuel on airplanes, then why don't fighter jets use them? It looks like an obvious upgrade. But in aviation, the obvious answer is often the wrong one. And the real reason has everything to do with speed, physics, and survival. And here's the first shock. Winglets actually help planes save fuel. But in fighter jets, they can reduce performance in the exact situations where survival depends on maximum agility. What winglets actually do. To understand why fighter jets avoid winglets, you first need to understand what winglets are designed for. On commercial aircraft, wings create something called wingtip vortices. These are swirling air patterns that form at the ends of wings. They create drag, which slows the aircraft down and increases fuel consumption. Winglets reduce these vortices by controlling airflow. This improves efficiency, reduces fuel burn, and increases range. For passenger planes, this is perfect. Because their goal is simple: fly long distances, use less fuel, carry passengers safely. But fighter jets have a completely different mission. They are not optimized for distance. They are optimized for combat performance. And that changes every design rule. Speed and agility matters more than efficiency. A fighter jet's job is not to travel efficiently. It is to react instantly. It must be able to accelerate rapidly, change direction sharply, perform extreme maneuvers, and survive high-speed combat situations. This is where wing design becomes critical. Winglets add structural changes to the wingtip. That extra structure can interfere with roll rate, how fast the jet can tilt, maneuverability, and aerodynamic responsiveness. In combat, even milliseconds matter. So instead of optimizing for fuel, engineers optimize for control and agility. A slightly more efficient jet that responds slower is a failure in combat terms. But there's another deeper issue. Because winglets don't just affect performance, they can actually become a disadvantage in high-speed combat environments. High-speed airflow is different. At the speeds fighter jets operate, airflow behaves very differently than in commercial aviation. Passenger planes fly mostly in stable, predictable air conditions. Fighter jets, on the other hand, operate in supersonic speeds, high-G maneuvers, sudden altitude changes, and unstable airflow conditions. At these speeds, wingtip structures like winglets can create unwanted turbulence, increase stress at wing joints, and reduce aerodynamic stability during sharp turns. In combat scenarios, stability under extreme motion is far more important than efficiency in straight flight. So engineers prefer simpler, cleaner wing shapes. Structural weight and stress limits. Every added structure on a fighter jet comes with a cost. Winglets may look small, but they still add weight, increase structural stress points, and require reinforcement. In a fighter jet, weight is extremely critical. Even small increases can reduce acceleration, climb rate, payload capacity, and fuel efficiency in combat maneuvers. So instead of adding extra parts, engineers remove anything unnecessary. A fighter jet is essentially stripped down to only what is required for performance. Nothing extra survives design review unless it provides a direct combat advantage. Winglets fail that requirement. But here's something even more interesting. Modern fighter jets actually solve the same aerodynamic problem in a completely different way, without using winglets at all. Advanced wing design replaces winglets. Instead of adding winglets, fighter jets use advanced wing shaping techniques. These include swept wings, blended wing-body transitions, controlled vortex generation, and digital flight control systems. For example, many modern jets are designed so that airflow is managed across the entire wing surface rather than concentrated at the tips. This reduces the need for winglets entirely. In fact, in high-performance aviation, engineers often prefer integrated aerodynamic design instead of add-on structures, because integration is stronger, faster, and more reliable under stress. Stealth also changes everything. Modern fighter jets are not just about speed, they are also about stealth. Winglets can increase radar visibility because they add extra edges and surfaces that reflect radar signals. Stealth aircraft are designed with smooth, continuous surfaces to minimize detection. Every angle is carefully calculated. Adding winglets would create extra radar reflections, which is exactly what stealth aircraft try to avoid. So from a stealth perspective, winglets are a disadvantage. Real-world design examples. If you look at modern fighter jets, F-22 Raptor, F-35 Lightning II, Su-57, J-20, none of them use winglets. Instead, they use carefully shaped wings designed for agility, stealth, and high-speed stability. Every surface is part of a larger aerodynamic system. Nothing is added just for efficiency unless it improves combat performance. But there's still another reason most people don't think about. Because fighter jets don't just fight in the air. They fight against time itself. Maintenance A&D operational limits. Military aircraft are designed for rapid deployment and maintenance efficiency. Adding complex wingtip structures like winglets would increase maintenance time, increase repair complexity, and reduce operational readiness. In military aviation, availability is critical. A jet that is grounded for maintenance is a jet that cannot be used in combat. So simplicity is a strategic advantage. Cleaner designs are easier to maintain, repair, and upgrade. Fuel efficiency is not the priority. Passenger aircraft care about fuel efficiency because they fly long commercial routes. Fighter jets do not operate that way. Their missions are short, high-intensity operations. Fuel efficiency matters far less than thrust, maneuverability, acceleration, and survivability. In combat scenarios, winning matters more than saving fuel. So even if winglets improve efficiency, they do not improve combat effectiveness. And that makes them unnecessary. And when you combine all of this, you realize something important about fighter jet design. Everything is sacrificed for performance in extreme conditions. Why clean wings when in combat? Fighter jet wings are not designed for comfort or efficiency. They are designed for extreme physics. At high speeds, under high stress, in unpredictable environments. Every design choice is about survival and advantage. Winglets may look like an upgrade in commercial aviation, but in military aviation, they are a limitation. So instead of adding them, engineers remove them completely. So the next time you see a fighter jet with clean, sharp wings, remember this: it is not missing winglets. It is built to survive a world where winglets simply don't belong. If you enjoyed this breakdown, there's a whole hidden world of engineering decisions like this happening everywhere around us. And once you understand them, everyday technology starts to look completely different.